Okay, so now we're up to lesson 3. I've taught you the information that you needed leading up to it. We've talked about quadratics, we've talked about x-intercepts, roots. Now let's see how all of this plays out for us. Lesson 3, zeros, roots, x-intercepts, and something called discriminants. So all quadratic functions have 2 roots. We also call these zeros. Remember that a root is, well, quadratic first of all, is anything in the form y equals ax squared plus bx plus c. Okay, that's a quadratic. And I want you to start using the more formal way of talking about it, using function notation, where it will be y of x. So y of x will be ax squared plus bx plus c, and I explained that more in detail in the previous videos. Now a root is different. A root is something, or is an x value that will allow the y to equal 0. Okay, so any value that will take a quadratic and make this part equal to 0 is called a root. So it's anything that will satisfy this equation is called a root. Another word for it is a 0. So Olivia, you and I were talking about language and the language goofing you up. If you remember that roots are also called zeros, then that'll help us to remember that those are any values that will allow the quadratic to equal 0. Now, so let's see. So any quadratic function will have 2 roots. That is 2 values of the variable that will make the function equal to 0. The zeros or roots may correspond to x-intercepts if they're real roots, meaning that they're members of the real number system. So they may be x-intercepts if they're real values. If, however, whatever satisfies this equation are complex or have imaginary numbers part of them, then the curve will not touch or cross the x-axis because they cannot be graphed on a real number plane, okay? Because they're imaginary. They don't have anywhere to go. There's no values that correspond to the imaginary values. So, let's look below. If we have 2 distinct real roots, then the quadratic function intersects the x-axis at 2 distinct points. If we have 2 equal real roots, then the quadratic function intersects the x-axis at a common point. And if there's 2 imaginary and complex roots, then the quadratic function does not intersect the x-axis. Here's some graphs for you. So you can tell that this one does hit the x-axis, which means that zeros for this quadratic will be real. They'll be real numbers. This one hits the x-axis, which means that the roots will be real numbers, but more than that, that they'll be equal to each other. This one, you notice that it doesn't hit the x-axis. That means that the roots of the equation are imaginary. They're complex numbers. They do not hit the x-axis. And we sort of talked about that more in class, and what we can do is sort of look at something called the discriminant to help us with that. Now the discriminant is going to be the value that's underneath the square root sign in the quadratic formula. So the quadratic formula looks like this: minus b plus or minus square root b squared minus 4ac over top of 2a. Those will give you your x values. Now, this is your discriminant. This is defined as the discriminant. It is b squared minus 4ac. That value. That value is very important. If that value is a number greater than 0, then we're going to have 2 real roots. If this value is equal to 0, then we're going to have 2 equal real roots, 1 x-intercept. If this value is negative, we're going to have an imaginary part to this complex number, which means that we will have no real roots and no x-intercepts. So again, using math language, what that looks like is, if it's greater than 0, then we're going to have two distinct real roots and two x-intercepts. If it's equal to 0, then we're going to have two real roots, but they're identical. So we have two identical real roots and one x-intercept. And if it's negative, then we're talking about getting a negative underneath the square root sign. And you're talking about imaginary numbers. Therefore, there's no real roots, cannot be put on this entire plane. And that means that there is no x-intercept. Okay? So that's summarized down here. I've got some extra stuff written up from the lesson. You can sort of forget about that. I'll talk about that in a minute. But this summarizes everything that we needed. I'd like to talk to you just for a second about how this works a little bit more in depth. You are going to remember that if I have a parabola, that parabola, I'm going to start off with this. If I have a parabola, that parabola has an axis of symmetry that's going to go straight through there. Okay? That axis of symmetry, as we've spoken about earlier, is given by negative b over 2a. Okay? Given that this quadratic has the equation ax squared plus bx plus c, where a, b, and c are elements of the real numbers, and a cannot equal 0. So this is what we have for this quadratic. This axis of symmetry will be here. Now let's think for a minute. If I have the quadratic formula that looks like this, minus b plus or minus square root b squared minus 4ac over 2a, and if I break that up into fractions, negative b over 2a plus or minus b squared minus 4ac over 2a, let's think of what happens with this discriminant. If this discriminant is 0, then it's going to be 0 over a number. Remember, a cannot equal 0. So it's going to be 0 over number. So it's going to be negative b over 2a plus or minus 0, which is going to give you a root, and only one that you can think of, or an intercept, at this point. Because you're not adding or subtracting anything. You're adding and subtracting 0, which doesn't take you anywhere. So if the discriminant is 0, notice that you're only going to have one real root. And remember that this number is going to be a real number because it's negative b over 2a, and b and a both came from the real number system. We didn't take a square root, so there's no chance of getting an imaginary number. Now notice if I get a value under this square root. Let's say I get a numerical value. Then what's going to happen is I'm going to have two x-intercepts this time. Because what happens is it's going to be negative b over 2a, and it's going to have to move root b squared minus 4ac over 2a this way, and it's going to have to move b squared minus 4ac all square rooted over 2a this way. So we're going to start at your axis of symmetry, and one root will be this way, and one root will be this way, and that gives you two distinct real numbers, which will give you two x-intercepts. Now the last case is what happens if this is negative. Well, if this is negative, then we're going to have a negative under the square root. I'm going to have complex numbers, and I'm not, so with this one, this was the x-intercept. With this one, I just moved it so that the x-intercept, the x-axis was above it. But in this one, where if I have a negative under here, then there can be nowhere to put those roots. Those roots can't go anywhere, which means the value that makes the quadratic equal to 0 cannot be graphed on it. And what you're going to have instead is the graph of all the real values, but not any of its roots, because its roots are complex. Hope that helps a little bit. And finishing off lesson 3, I'll do the 3 examples in the next video.